The physical infrastructure of a modern enterprise data center reveals the scale of the autonomous AI workloads now driving the market. The volume of these non-human identities is vast. Today, the enterprise attack surface is defined by an 82-to-1 ratio, 82 autonomous agents operating for every one human identity. Most organizations manage this risk through content filters and prompt guardrails. These mechanisms ensure the AI remains polite, placing them within the engineering domain of AI safety rather than system security. Technical security requires absolute control over the execution layer. It mandates hard-coded restrictions on which files an agent can touch and which system calls it can execute at the kernel level. Because autonomous agents scale instantly and operate without human intervention, any architectural blind spot in execution security multiplies the attack surface exponentially. To isolate these workloads, enterprises utilize the NVIDIA OpenShell execution plane. OpenShell relies on two underlying Linux kernel primitives, landlock LSM for file system isolation and seccomp BPF for system call filtering. This kernel-level enforcement is configured using a static sandbox profile YAML file, which is loaded the moment the sandbox is executed. OpenShell evaluates execution parameters. The agent passes but holds a stolen token. OpenShell controls what can be executed, but cannot see who the agent is. If an identity is compromised mid-session, the static sandbox lacks a detection signal. The execution loop continues unbroken. Relying solely on execution isolation leaves a significant authorization gap. A secure sandbox will still execute a data breach if it cannot continuously verify the identity of the workload inside it. EnforceAuth addresses this by operating as the identity plane, running as an isolated sidecar process alongside the agent workload. The process begins with token ingestion. EnforceAuth uses SPIFFE and SVID workload binding to prove the incoming identity matches the exact physical Kubernetes pod making the request. This interface shows the Open Policy Agent, or OPA, evaluation engine. The EnforceAuth Rego policy is visible here. Default allow equals false. This is the architecture of default deny. By requiring an explicit match for every parameter, the absence of a rule blocks access, preventing accidental authorization. Authorization is not a one-time gate. Every action the agent attempts triggers a per-request reevaluation against a live, OCI-distributed data bundle. Because this runs in process with a warm cache, the continuous evaluation completes in under 2 milliseconds. This shift replaces static pre-flight checks with a real-time, identity-aware security lifecycle. The primary engineering challenge is translating a dynamic JSON decision from OPA into a static OpenShell kernel rule set without manual intervention. This node-level topology diagram shows the F3 connector positioned between the agent pod and the EnforceAuth sidecar. It operates as a privileged out-of-process translation bridge. When OPA evaluates a request, the JSON payload includes the decision and a specific OpenShell profile string. The F3 connector acts as a profile resolver, mapping that JSON string directly to a named sandbox profile YAML block. For isolation, F3 runs in a separate PID namespace and applies this YAML using the OpenShell internal API. The mapping from decision to profile is read-only at runtime. The agent process tree has no write access to the configuration. This out-of-process isolation ensures that even a root-compromised agent cannot intercept its own policy evaluation or alter its kernel rule set. We can trace exactly how high-level identity scopes dictate file system control. The allowed paths array generated by F3 maps one-to-one with landlock access flags, such as landlock access fs read file. Similarly, EnforceAuth dictates system call filtering through the additional syscalls array inside the sandbox profile. This array maps to the seccomp BPF allow list loaded into the kernel. This architecture eliminates manual rule set authoring. Identity governance is automatically compiled into absolute Linux kernel enforcement. Consider a compromised agent attempting to spawn a subagent with elevated privileges to write to a configuration file. This is the EnforceAuth scope inheritance tree. Permissions flow from the root agent to subagent A. When subagent B requests an elevated scope, a denial is triggered. The Rego engine checks the request against the parent's permission ceiling, blocking it at the identity layer. Because the denial happens before F3 takes any action, the OpenShell sandbox for that subagent is never instantiated. Continuous policy enforcement neutralizes local escalation attacks. Unauthorized workloads are prevented from reaching the execution layer. Consider the mid-session authorization gap. 30 seconds into an active session, an agent executes unauthorized API calls before its credential is revoked by security. The enterprise identity provider emits a skim patch, signaling that the identity is no longer active. The EnforceAuth WebSocket listener intercepts this signal and invalidates the token in the OPA data bundle. At the agent's very next action attempt, the OPA evaluation fails. The F3 connector synchronously issues a revoke command directly to the OpenShell API. OpenShell clears the landlock rules and issues a process group sigkill, terminating the agent. This entire sequence, from IDP revocation to kernel-level termination, executes in under 50 milliseconds. Every decision generated by OPA produces a hash-chained, tamper-evident record with a unique decision ID. This exact decision ID is automatically injected as an annotation into the OpenShell kernel execution event log. This correlated record satisfies the audit requirements of global frameworks, including DORA, HIPAA, and the EU AI Act. By engineering a low-latency bridge between continuous identity evaluation and static kernel enforcement, organizations achieve a mathematically provable security lifecycle for autonomous AI agents.